I welcome you all to the new topic on the Numpy, that is a hyperbolic function. This comes under the universal functions that are inbuilt in the Numpy. What exactly is a hyperbola? Hyperbola comes under the conic sections. First of all, we need to discuss about it. If we take two cones, one up and one down, and we take it as the axis, this is somehow axis, and we cut the axis using a plane at a 30-degree, we're gonna get a parabola. This structure is termed as a parabola. At the same mode of time, if we cut a particular axis, this axis with a 90-degree, we're gonna get the circle. And if we cut a particular axis with a 60-degree angle, we're gonna get the ellipse. And at the same mode of time, if we cut this particular cone with a 180-degree, we're gonna get the hyperbola. Hyperbola is nothing but the two of the parabolas that are approaching each other. This is some parabola and this is some parabola that are approaching each other. This is called as a hyperbola. And this hyperbolic function that includes the sine, cos, tan, cot, and cosec and sec. These are extensively used in the machine learning or the deep learning as activation functions. Activation functions are nothing but these will activate the inputs. For example, if my activation function set to 1 and I got the input as a 0.98, then it is not gonna activate the output. At the same mode of time, if I get 1.12 as my input and the activation function is 1, then it is gonna trigger the output. And this is why the activation functions are used. And the activation functions have a broad classification in the machine learning, and I'm going to discuss in further presentation of further videos. For this, I'm going to discuss how the activation function work, I mean the hyperbolic function work using the Google Colab. Here we have the three hyperbolic function: sine, cos and tan. First of all, I want to visualize the things. Visualization can be done using the matplot library py.plot, and I'm going to visualize how the activation function look like the hyperbolic function look like. First of all, the sine hyperbolic of x can be represented as e raised to x minus e raised to minus x by 2, whereas the cos of hyperbolic is represented with the e raised to x plus e raised to minus x by 2. And as we know, tan is a ratio of sine by cos, and we're gonna get these values. And I'm going to use some set of the values over here that starts from minus 790 to plus 790, and I'm going to use the hyperbolic of sine, and I'm going to visualize this thing using some plot library, the matplot library, and I'm going to run this particular thing, and you're gonna get this value. This is also termed as a sigmoid function, sigmoid activation in the machine learning, and this is caused by the sine hyperbola. As you can have a look at here, it is half of the hyperbola. Here we have half of the parabola. Here we have the half of the parabola that constitute full hyperbola, and this is how sine hyperbolic function look like. Actually, it is not a stiff curve. You're gonna get a stiff curve if you use a lot of values over here. I just jumped from 790 to 540. If I use a lot of values in between this, we're gonna get a smooth curve over here. And after that, I'm going to use the cos, and the cos is nothing but parabolic look. It look like a parabola. And after that, we have the tan. If I use tan over here, you're gonna get the values like this. This is how tan hyperbolic is used. Tan hyperbola and sine hyperbola are extensively used in the format of sigmoid and LSTM, and I'm going to discuss it in further. And this is how we're gonna go with the hyperbolic functions. Now I'm going to discuss about the inverse of the hyperbolic functions. We have successfully created the hyperbola. Now to convert that hyperbola like hyperbolic functions normal back to the normal degree or the radian, we're gonna use this particular tan. Like here we have x, and I'm going to use x over here. And first of all, I'm going to use sine h, and I just save it, and I'm going to visualize this particular thing using the z, and I just run this particular program. As you can have a look at here, we're gonna get the z values. These are the z values. If you compute it using np.pi by 40, you're gonna get these values only. And after that, we have the cos. Just remember, we're gonna get the values same, but in the reverse manner. I just save it, and I just run this particular program, and as you can have a look at here, we're gonna get the values, and the same with the tan. You're gonna get the values of the tan, and this is about it. Well, do subscribe our channel for regular updates. Thank you.